I am so excited for today's IPC because I like science, I like history, and I love this topic, footprints from the past. So let's see what we're going to be doing today. You might want your whiteboard and a pen. You might want to take notes. And remember, pause the video whenever you don't understand something, rewind it and watch it again. There's going to be lots and lots of information today ready to help you do your activity. Today, we're going to be learning all about fossils. And we had some kind of idea from last week because you did some amazing research about Mary Anning, who's a paleontologist, which means that she studies and she all about dinosaurs, and that includes fossils. Because fossils help us know about prehistoric life. But let's look at that in more detail. First of all, I want to ask you the question, are dinosaurs real? Now, if we're in school, I would say, discuss this with your learning partner, but you don't have one. So, who could you go and ask? Pause the video now and go and have a chat with someone at home about whether dinosaurs are real. Think about what evidence you have to whether they're real or not. And where does that evidence come from? So pause now and go and find someone to ask the question, are dinosaurs real? Go, quick. Okay, so you should have had a really nice chat with someone at home about dinosaurs and whether they're real or not, what evidence there is. So let's take a look. It's believed that dinosaur fossils have been found for centuries, and these give rise to many of the kind of ideas we have about dinosaurs. However, if we didn't have the documented evidence, we cannot know for sure whether they did. What we do know is that our current knowledge of dinosaurs and paleontology, which is the study of fossils, started in the 1800s. So that means that we've only known about dinosaurs for 200 years. We know about dinosaurs due to the discovery of fossils and fossilized skeletons. So the answer to the question, yes, dinosaurs are real thanks to fossils and paleontologists who study them. All right, let's work out the difference then between bones and fossils, because many of us think a fossil is just a bone that's been preserved over time, but that's not true. So let's take a look. Bones are a tiny piece of white, hardish kind of tissue that makes up the skeleton in animals and humans. Okay, so we have bones in our bodies, so do animals, and they're whitish, hard, made of calcium. Fossils, however, fossils are more than just ancient bones. And there are many, many types of fossils. Okay, so what happens over time is that skeleton, that bone, may actually disintegrate, so disappear, but it leaves a mold. Okay, a bit like this picture here, this is a mold of a footprint. Or this picture here isn't actually bones, okay? So fossils mean that this is actually some different minerals that make up the same shape, okay? There is some awesome videos at the end of the slides, okay? So you can go and have a look a little bit more. But I wanna move on to the different types of fossils that we have. Fossils are the remains of traces of plants and animals that lived long ago. Fossils give scientists clues about the past. For this reason, fossils are important to paleontology, or the study of prehistoric life. Now, I didn't realize that fossils could be plants as well. And I think that is the most important thing, is the fact that because of fossils, we know so much about millions and millions of years ago, before even humans existed. And there's loads of different types of fossils that we're going to study in a minute. Why are they important? Because they teach us about the past. They teach us about different creatures that used to live on Earth that we'll never have the chance of meeting or experiencing. Where do we find them? Look at this map, okay? This is a world map, and they are found all over the world. They've been found in Central America, they've been found in Brazil, Argentina, even the Antarctic has found prehistoric fossilized sea creatures and reptiles. There have been some in China, quite a few in Germany and Europe. England even is in a place called Lyme Regis, is quite known for fossils, and Egypt. So these aren't all the places that have them, but these are the ones where you can kind of find a lot. And this is where paleontologists will probably do most of their research. But more importantly, where do we find fossils? So they're the countries where we find them, or some of the countries, but we find them in rock. Okay, we find them in what we call sedimentary rock. And what that means is there's been layers and layers and layers and layers and layers of rock that have built up over time, and they've been squashed. Okay, and you can see here, this is what we call a cast or a mold, because this isn't bones, this isn't anything like that. What this is where the animal died and the rock kept getting squashed and squashed and squashed, it left a print, basically. And this is another one here of a print. So these are fossils, and we find them in sedimentary rock. All right, so there are different types. We have trace fossils, mold and cast fossils, replacement fossils, and whole body fossils. Okay, so pause the video now, and I want you to have a think. What might a trace fossil look like? What might a mold and cast fossil look like? So have a little think. Pause the video and see if you can understand what these words mean already. And at this point, it might be a good idea for you to make some notes, like I said. So you might want to pause the video and just write the names of these fossils down, because now we're going to look at each different one. Starting with the trace fossils. These are fossils that record the activity of an animal. So they look a little bit like this. Footprints, trackways, which are more than one footprint, so you can see the distance, and even fossils of dinosaur tails being dragged along the way they walk are part of trackways. And my favorite, coprolites, which is basically poo. Yeah, that's right, it's poo, which is really fascinating because poo, feces is the scientific name, so you can see I've spelled it there, feces. It decays really quickly, so it disappears, okay? It breaks down really quickly. So in order for it to be fossilized, it takes thousands of years, millions of years. So it's really amazing to think that we have, paleontologists have found dinosaur poo. Yeah, I'll leave that one with you. It fascinated me too. All right, body fossils. Body fossils are the remains of an animal or a plant, such as bones, shells, or leaves. And there are three types. So we have mold and cast fossils. Mold fossils form when all of the parts, including the bones, have decayed, so they've disappeared, and all that is left is a nice mold or an imprint, a bit like the one I showed you earlier. Cast fossils form from mold fossils as the mold fossil is filled up with sediment. So this is not made up of the original matter either. So what that means is there was a mold. So imagine this shell here, the shell's not in it, and it's just left a print. But then the cast fossil is when more and more and more dirt and mud and rock fills it, it makes a cast, almost like a 3D shape of it. Replacement fossils, okay? These are formed when water dissolves the original hard matter of the bones, and it replaces them with minerals. This is what we think of when we discuss dinosaur fossils. They still look like bones, but they're not made up of what bones are. They're made up of other minerals. So quite often we say, oh, look, this is a skull, which it is if it's bone, but if it's a fossil, it will look like a skull, but it's made up of different minerals because of the water that's made the bones replaced. And then the last one is whole body fossils. Whole body fossils, a bit like the trace fossils, are the easiest, because this is when the whole body of the creature or the plant has been preserved, which means that we can see the entire shape. So the skin and the muscles, they decay, which means they, disappear as we think, and we're left with the perfect shape of the animal. And when you go to visit museums, you see whole body fossils of dinosaurs, which is incredible. All right, so trace fossils in simple form are footprints and dinosaur poo. Then we have cast fossils, which is when it makes a print and we are left with the print. Mold fossils is when the print is filled in and it makes the shape look like the original shell would have done. Whole body fossils is all about seeing the whole animal. Okay, I told you there was going to be a lot of learning today. I hope you are making notes, and I hope you're ready to go through the fossilization process. Okay, so this is how fossils actually happen. And we're going to look more importantly at ones that kind of use heat and rocks to change the fossils. This is going to be part of your activity today. So I really want you to take note of the pictures and the words, because you're going to have to do a matching activity for me. But I'll talk about that later. Okay, step one. An animal or creature dies. Okay, that's step one. And it gets covered by layers of sediment. And that special scientific word means plant materials or tiny parts of rock. So as you can see, the dinosaur, bless him, has died, and then there's a layer of sediment on top of him. Over time, through compaction, which means pressing down, these eventually form rock. Okay, so now the dead dinosaur is compressed with rock. Step two, have a look at the picture. Over time, more layers of rock are formed which cover it, and by this time, the only remains of the organism would be the hard parts, such as bones, shells, or teeth. So the pictures change. I'm just going to go back to step one. Here's step one. Creature dies and it's covered with sediment and pressed down. Step two. Now it's completely underground. It's being compressed so much, the only thing that's left is bones, teeth, and shells. Step three. Over thousands of years, the mold fossil becomes a cast fossil with sediment entering in the mold. In the case of the replacement fossil, the original bone matter might change. Okay, so here, the bones have now decayed. So as you can see, the dinosaur is like a darker color. Here was the light color in step two. That means the bones have disappeared. They've decayed so much over thousands of years. And now they've been made into a mold of what it used to look like, or they've been replaced with different minerals. I hope you're still with me. Remember, pause and rewind if you're not. Moving on to the next step. This one's the trickiest one because the picture almost looks the same. Over a long period of time, the sea will recede in certain places. That means it will come backwards. The sea level could also be changed quickly through earthquakes and volcanic eruptions. Okay, so what that means is where that perfect land was nice and flat, maybe a volcano's come out through uplift, or maybe an earthquake's made it a little less stable. Okay, so we start to begin to uncover fossils because of the sea level and earthquake and volcanic eruptions. Is this step 5? Is this the last step? As erosion and weathering takes place, eventually the fossils become exposed. So what that means is when we have really huge storms and thunder and lightning, and when that sea keeps hitting into the rock, what it does is it wears it away. Okay, and what happens is now you can see the dinosaur is on the outside of the rock, which means paleontologists will go and discover them. Okay, so we've got 5 steps to fossils. Step 1, creature dies and is covered by soil, mud and rock. Step 2, can anyone remember what step 2 was? Maybe you need to go and rewind, okay? Please do that and watch the processes again. Take a really good look at the pictures because we're going to talk about your activities. Step 1, you are going to find this page on the response, and I want you to tell me what is a fossil. Remember the difference between a fossil and a bone, and see if you can use all that knowledge that I've given you about different types of fossils to write or record your answer. The next activity, look, here are the pictures. What you need to do is you need to match the pictures to the words. So when you go to Seesaw, you'll see all the words, and I want you to tell me which was step 1, step 2, step 3, step 4, step 5, and you can move them around, you can play with them, as long as you get them in order with the right words. Okay, I want to know from start to finish. So for example, which one would be the first picture? What was step 1 of the fossilization process? What was step 2? That's why watching the video again might be helpful. Okay, and then the last thing I want you to do is have a little read, okay? I want you to think about some English now and have a little read of fossils, because then you're going to have some questions to answer. Okay, so rewind. We've learned what fossils are, we've learned where they come from, and we've learned how they are formed. Huge, huge, huge knowledge lesson today, science and history. Have a really good go at the activity. Tell me what fossils are, match the picture to the right words in the right order, and then answer the questions about the reading page. Enjoy as much as I enjoyed learning all about fossils.